All right, ladies and gentlemen, good morning. So here we are at activity for processing 2.11, where we're going to be preparing for cooldown 2.11. So please, ladies and gentlemen, do not watch this video without bringing out your notebook, and make sure you do hit the pause button on the video. When you hit the pause button on the video, ladies and gentlemen, it gives you an opportunity to write down notes and create your own annotations and side notes on the margin of your paper. So if you're taking notes here on the middle, you can always add notes on the side here. You can always draw arrows and annotate, but please do not watch these videos without taking notes, ladies and gentlemen. It is the best practice when watching anything in any class is taking notes, so that you have a permanent location for them to be recorded. So in the future, when you take your quizzes or you need to reference before a midterm or a final, those are there available for you, all the highlights in one convenient spot. Okay, without further ado, let's begin. So for this particular cooldown, they're gonna ask you to determine where is the location or locations that f of x and g of x intersect with one another. Now, sometimes there are a few cases where they do not intersect, but we will not be exploring those during this activity. So allow me to just draw something that doesn't actually show f of x and g of x. It's just like an example of what it is we're trying to do. So let's say f of x, which we're going to call f, looks something like this. We're just going to call it f. And g looks like this. Okay, I'm not saying they look like this. I'm just saying pretend. Okay. What I'm trying to draw your attention to is that the points where they intersect, those are your solutions. Okay. Now, I would highly recommend, in order to check your answers for the classwork and the cooldowns, if you haven't downloaded this yet, please do so. Desmos, you can always plot these graphs. Click here, and then it'll bring up the location of the solutions or intersection of the two graphs. So that's what this whole cooldown is about. It's saying, where are the solutions, AKA the points of intersections of these two functions, okay? So if you go on Desmos, it looks different than this. Don't say I didn't warn you, okay? This is just an example. Okay, so we're not going to be submitting a graph to show the points of intersection in this particular lesson. What we actually are going to do is calculate through the use of algebra and multi-step solving equations. And that's what the focus of this video is going to be for. So allow me right now to do this. We want to know what points of intersection exist between f of x and g of x. For the sake of simplicity, I'm going to call f just f, and g of x just g. Now, think about this. Let's say you are here, and your friend is over here. Where are you guys equal, right? Where are you folks in the same location? Well, you're not. One of you's over here, one of you's over there. But let's say you guys give each other a high five right here at this point, okay? You guys give each other a high five. Right here, where you guys meet, you two are equal. So that's what I kind of want to display here is we're setting them equal to each other because where they touch, where they are equal to each other, those are your solutions, okay? Hope the stick figures spicing the analogy up a bit. So now that we have set these two equal to each other, we're going to find out where do they give each other a high five, where do they touch, where do they meet, and therefore those are where the locations are of these two functions. So we're going to write down f of x on the left side. Okay, there it is. And on the right hand side, we're going to write down g of x, or just g. Okay. Now, I know that all the parentheses and stuff might be a little misleading, a little confusing. So just let me just point where I got these factors from. Okay, this is f of x. Just put it right here. And over here on this side, this is g of x. Just put it right here. Okay. And if it helps, I'm just going to circle them. Okay, that's what I placed here. And this factor I placed right here. And now they're equal to each other. Now comes the algebraic, the steps, the strategy. How do we solve for x? Because we don't know the value of x. Okay, so what I do notice here is that both sides of the equation have one factor in common. They both have x plus 3 in common. That's very convenient, but what I can do next is subtract that factor, or as we also reviewed in class, it's also called a quantity. Okay, so we're going to subtract the quantity x minus 3 from both sides. So you have a quantity above that is losing an exact value. When you have two values that are exactly the same and they're being subtracted from each other, for example, 5 and 5 are the same, and if I put them in parentheses, this helps you visualize more. 5 minus 5 equals 0. Same thing here. So we have x plus 3 minus x plus 3. Oh, missed a little plus there. There we go. There we go. So they are the same exact quantities. So once that happens, ladies and gentlemen, we get 0. I'm going to scoot this over just a tad bit because we're going to need some more space. You'll see in a moment. Okay, so these cancel out because they are identical values that are being subtracted from each other. Next. So you might think that these cancel out too, but they don't. That's because x plus 3 is not by itself. It has a friend next to it, and this right here inside these square brackets, it's its own independent quantity. So you cannot just simply subtract this quantity from this large quantity here. So since we cannot do that, we have the option to actually just rewrite it horizontally. Okay? So now I can factor out the x plus 3 that they both had in common. Okay? So in order to factor out, I'm going to set up a product of two quantities. And here is the spicy trick here. So I pulled out x plus 3 from the difference of these two values. Next, I need a leftover basket. That's what I'm going to call this, the leftover basket. And this is where I write all the leftovers. So x plus 3 was being multiplied by this quantity, x minus 2. X plus 3 was also being multiplied by a quantity, ladies and gentlemen, but it is not visible. But we've talked about this before. You make the invisible visible, and the coefficient of every single quantity is a 1. Okay, in this case, since we're subtracting, it's a -1 that we're going to place here. So if this is causing some discomfort right now, do not worry. You're going to see in the next few examples more practice with this particular step, because I predict this is where the most trouble might come from. Okay, but don't worry. I'll touch on this some more on the next 2 examples. Okay, so now what we do here, -2, -1 give us -3. We already know how to get the zeros from a factor. We just switch the sign. So those are our two x values. So this question asks us, where do these two graphs intersect, right? Now, it's true that both of them have these x values, but an intersection, ladies and gentlemen, is not an x value. It is a coordinate pair. It's a location on an xy axis. So our answers actually have to be in xy format. So how the heck do we get these things here? That brings us to our next point. Remember at the beginning when we were saying like, what does X need to be, right? We don't know the value of X. Well, now we do. So what we're gonna do is we're gonna plug these values of X back into their respective equations and actually do that. Now, unfortunately, this does require me to erase here. So what I'm gonna do is I'm gonna erase this chunk here. I'm gonna try to write small here. Here we go. Should I erase the whole thing? I don't know. We'll see. I think I can squeeze it in there. Okay. So what we're gonna do is F is equal to X plus 3, X minus 2. So we're gonna do this for -3 first. So when X equals -3, when X equals -3. Okay, so let's plug -3 into the equation. -3 plus 3. You notice I'm replacing this X with the -3 that we got right here, okay? Now this one right here is also a 3. 3 minus 2. Okay, so we got -3 plus 3, that's 0. 3 minus 2, that's 1. Multiply them together, it gives you 0. Cool. So the first one's going to be -3, comma 0. Okay, so we already did -3. This is the next one we need to do. We need to find the second coordinate pair because there are 2 X values. And right now I can predict the question, Mr. What if I had 3 X values? Then you're gonna have 3 coordinate pairs, okay? So let's go ahead and plug this one in. And we're gonna call this one when X equals 3. You can put +3, that's fine, but I'm just gonna put 3. Okay, so this time I'm not gonna replace X with -3. I'm gonna replace it with 3, okay? So this time it's 3 plus 3 and 3 minus 2. Okay, 3 plus 3, that's 6. 3 minus 2, that's 1. 6 times 1, that's 6. Okay, 3. And when we plug 3 in, our output was 6. Why? Okay, so if we put this into decimals, we should be able to see 2 graphs that intersect here and here at 3, 0 and at 3, 6. All right, let's go ahead and hop into the next example. Well, actually, before I do that, let me just give a quick run through of what I did here, right? So I set the 2 equations to each other. I subtracted what they both had in common from both sides. And here's the little step that might confuse you, is you're gonna be required to factor out and put an invisible coefficient of 1 in the leftover basket. This I will touch upon. The rest is just solving and simplifying. Once you get 2 or more X values, or less, sometimes you get 1 X value. Once you get your X values, you plug them back into the equation and replace the X's to find the Y. There's the first one we got, and to find the second Y. There's the second Y we got. All right, let's go ahead and hop into example 2. So right now I'm gonna ask, if you feel like, hey, I think I get this, let me try this problem on my own. Right now would be a great opportunity to set up and skip a line. Set up example 2, and after I write it down, you can write it down and pause the video and then try it on your own. Okay, so let's say F is equal to G. Let's say F is equal to X plus 6, X minus 1. And G is equal to X plus 6. Okay, there we go. You notice I didn't call it F of X, G of X. I could have, maybe I should have, but I just want to keep it simple, okay? Just don't want to introduce many parentheses and all this stuff, but focus more on the calculations. First thing, I noticed that the left-hand side and the right-hand side both have X plus 6 in common, okay? So what we're gonna do here is subtract X plus 6 from both sides. I didn't make a mistake this time, like I did on the last one. Next, I'm gonna subtract these 2 quantities which have identical values. Therefore, they cancel out. Next, I am going to write, and this time I'm gonna color code it, the first quantity, the product of these 2 right here. I'm gonna write them in blue. Go back to the purple minus the one that we subtracted. All right, here comes what I wanted to show you again, because in the last example, I know this is what maybe caught a few of us off guard. Make your invisible coefficient, make it visible. Okay, there's a 1 there. Next, we're going to factor out what these two values have. The first value, which is written in blue, has x plus 6, the quantity x plus 6. The second value, which I wrote in purple, and the pink, I guess, too, it has x plus 6 here. So what we're going to do is we're going to factor out x plus 6. And now we're going to create our leftover basket. So what are our leftovers? Boop, boop, boop. Those are our leftovers. Okay, we already used this up. We gobbled it up. Yum, 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 yum. There it goes. So the leftovers are x minus 1 minus 1. Okay, boop, boop, boop. I'll put the little dots there too to show you. There they are. Okay, let me erase them because they're going to look like exclamation points later. Okay. Once you get past this hump right here, this step, smooth sailing from here. -1 minus 1 is -2. Okay, and all you do is switch the sign. So you get x equals -6, and then you get x equals +2. Okay, now we have two options as to what we can do here, okay? On the last example, I showed you, hey, grab this x and substitute it here, then grab this x and substitute it here. That's what I'm gonna do again. So you might be asking, could I have substituted it in here? I'm gonna leave you to try that. All right, here we go. When x equals -6, I'm gonna plug it into this blue equation. I'm gonna put it in a cloud. Okay. I'm gonna put that here and here. This is gonna go here and here. So we have -6 plus 6 times -6 minus 1. Okay, -6 plus 6 is 0. So our output here is going to be 0. So we can say that our first coordinate pair, where is my, I guess I can use this, that's fine. Our first coordinate pair is going to be at -6, 0. I'm going to put a square around it. There you go, little star. There's my first location. Okay, let's go ahead and hop into the next one here. I'm gonna write in red, but this time I'm gonna draw a little wiggly line so the work doesn't get all pressed and jumbled up. Rather, so whoever picks up my paper or my work, they can see that there's a clear divide between the first value that I substituted and the second value. I also like this when people draw an arrow. So this is x equals -6, and then over here I'm gonna draw an arrow. This is x equals 2. Okay, let's plug it in. So we're gonna plug in 2. We're gonna plug in 2. 2 plus 6. 2 minus 1. You get 8, which is great. So when we plugged in our input of two, we got an output of 8. I'm gonna put a little square around that. There we go. So our two locations, if you check on decimals, are gonna be at -6, 0 and 2, 8, okay? All right, let's hop into our third example. And this one, once again, I'm gonna ask you, after I write example 3 and I write the question down here, pause the video, try it out for yourself. And then when you unpause it, let's see if we get the same thing. And it's okay if you make mistakes. That's totally okay. It's part of the learning process, y'all. No one learns something on the first try. According to data research, it takes about 7 different times to actually get the hang of something. And that's not even mastering it. That's just getting the hang of it. All right, so example 3, which is our final example. Here we go. We got F equals G. We're gonna set the two equations equal to each other. F is equal to the product of x plus 10 times x minus 7. And G is equal to the quantity x plus 10. All right, let's boogie. Okay, so you might be thinking to yourself, wait, I know the first step is to subtract from both sides, but what do I select to subtract? Well, you have to see, what do both sides have in common that you can subtract from both sides? Well, they both have x plus 10 in common. So always choose what they both have in common on both sides. Because look what happens. Boom. Okay, so now we got this long difference here, which we're gonna write out. And I'm gonna scoot this. I know people love their equation signs lined up, but this is just the nature of the beast. There's only so much screen space I got. Minus x plus 10. Okay, so if you are unpausing this video right now and you did this problem, shout out to you if you remember there's a ghost coefficient of 1 there. Okay, shout out to you if you recognize that we can factor out what both of these values have in common, which was x plus 10. And then the leftover basket. Boop, boop, boop. Boop, boop, boop. There you go. That's the tricky part here. If you can master that, the rest is pretty like, it's stuff you've seen before. Okay. All right. So we got x plus 10. Over here we have x minus 8 equals 0. So this one is x equals negative 10. Switch the sign. Switch the sign again. You get x equals 8. Awesome. We have our x values. But remember, the intersection of two functions on a graph are not values. They are locations. And locations always come in the form x comma y. This is your location. Okay, so let's find these locations. So we're going to plug negative 10. Let me use red. Let's plug negative 10 into this clouded or this circled, I don't know, this red stuff here. I should have wrote when x equals, for consistency's sake, sorry about that, when x equals negative 10. All right, so when x equals negative 10, we plug it in. Negative 10 plus 10, that is 0. Negative 10 minus 7, that is negative 17. And then 0 times negative 17, 0. I think I can write that a little smaller and just put my coordinate pair there. See if it comes out. Yep, it'll come out. So the x value was negative 10, and the output value, which is our y, right there. Put a box around that, and let's move on to the second x value. I'll do this in purple or black. Let's do it in black. Whoa. Okay, so this was when x equals negative 10. Next, I'm going to do it when x equals 8. Okay, it's not necessary you write when x equals. That's just something I've kind of grown accustomed. So if I ever go back to my own work, it's like, what did I do here? Oh, I solved for this when x equals blah, blah, blah. In this case, 8. Oh, let me point again. So we're going to substitute our value of x here and here, where the x's are at. So instead of x plus 10, we got 8 plus 10. And instead of x minus 7, we have 8 minus 7. 18 times 1. So we get 18. Therefore, our coordinate pair, it's going to be 8 and 18. Put a little box around that. Plug this in. Plug this equation into decimals. Plug this equation, because you can put as many equations you want into decimals, and I'll show you how again. Put this into decimals. Put this into decimals, and then click on the intersection points, and these should be it. Okay. All right. that is a wrap for how to algebraically solve for the intersection of two functions using algebraic steps, okay? All right, good luck, have fun, and then let's see each other in a little bit for more support.